On the IB Math Studies test, there is a little bit of calculus. However, it is the one topic that has the least percentage of the syllabus. It's just got a little bit of calculus in there. And I want to talk to you about one concept that is on the IB Math Studies test in regards to calculus, and it has to do with this little baby symbol right here, that little baby ticky mark. Now, that little ticky mark there is the symbol. It's asking you to take the derivative, or the international word for derivative is gradient. So gradient is the calculus word for slope or derivative. So in Algebra 1, you call it a slope. So gradient is the same thing as the slope. It's the same thing as the derivative. Those are all synonyms of each other. Slope, gradient, derivative. Except in Algebra 1, all the slopes are constant. All right, so this little notation here, that little ticky mark, is asking you to find the derivative. Sometimes they tell you find the gradient, or they'll just use symbols. And all that's asking you to do is to take the derivative. Now this particular question's got 19 parts to it, and 3 of those points is just doing a very rote derivative or gradient. Okay, so that's just a piece to the puzzle. So this is a question from 2010. It seems to be that these gradient questions always surface on paper 2. It doesn't mean it won't show up on paper 1, but usually on paper 2 it has a very lengthy multi-step question in where the gradient or the derivative is a part of it. I'm going to come back to this question and do part A, B, and C, or just, A, B, and C. But I want to show you another question. Here's another one from 2013, and here is a little ticky mark again, and that's asking you to find the derivative. Now this question has got 21 points. It's a monster question. I'm only going to go over the first 3 parts to it because the rest of the question is a lot of algebraic skills from Algebra 2 and Algebra 1 and even geometry, but this is the calculus portion video only. 2016. Here's our little ticky mark. Notice for each one of these, it has been part B, or it's been early in the question. This is a 13-point question. In this case, the function, instead of using f of x, the generic function, it's using h of t. So instead of, in the other previous questions, it used f of x. In this one, it's h of t. So it depends upon the little function here. If the original problem, for example, used y, if the function was in terms of y, then you would see here y ticky mark, also known as, you would say y prime in calculus, but it's really the gradient or the slope of the function y, okay? So, just because it uses the letter h and it uses the letter t instead of x, it doesn't mean you're doing anything different. It just has to do with this problem here is a application question where the y variable is in terms of height, and the x variable they're calling time in this case. All right, so I want to show you 3 different questions on paper 2, and all 3 of them ask you to find this gradient here. Now before I go on, I want to show you there's 3 purposes to this video. First of all, what is a derivative? Okay, in Algebra 1 you just call it a slope. In IB they call it gradient. Gradient, okay? Now that's just recalling facts, but I'm going to show you, if you allow me, give me about 3 minutes to tell you exactly what a derivative is from a concept point of view. The second purpose of this video is to teach you how to find the derivative. The good news is it's very, very repetitive, and it's a algorithm, it's cookbook, it's a little recipe. My son learned how to do it when he was 8 years old. He had no idea what he was doing, but if you know how to multiply and subtract, you can find a derivative. So that's the good news. It's one of the easiest processes on the IB test, and ironically, that is the calculus portion of the test, is something very, very easy. Okay, and then every one of these questions ask you to apply the derivative. This is the part that most students don't know how to do, that I teach. My strongest ones naturally know how to apply it, but my weaker IB students have a hard time applying the derivative. So I want to stress that at the end of the video and show you those three first questions that I showed you. Finding the derivative was earlier on in the question. That was like part 3 or part 2 of the question, and then there's multiple parts after that that deal with the application. Alrighty, so let's go back. First of all, I want to talk about what a derivative is. Now in Algebra 1, here's a equation in slope-intercept form. This is the y-intercept, so that means the line crosses the y-axis at 1. And the slope, or the gradient, would be 2/3. Okay, so I'm going to use both words here. And this would be an example point of how you get the slope of 2/3. So I'm just picking random points here. I just completely made this up, but here we get a slope of 2/3, or gradient of 2/3. And this is the formula that you use in Algebra 1 to find the gradient. You need to have two ordered pairs, an x and a y value. You plop it in and you get a slope, or you get a gradient. Okay? So when you're graphing this, if we have a slope of 2/3, that means it's up 2 over 3, and the slope is 2/3. So if you're asked what the gradient is of this equation, this linear equation here, the answer is simply 2/3. That's the gradient. Now that's a very, very basic question and answer, because the slope will always be 2/3. So even if I go over here, up 2 over 3, I'm still on the line. Up 2 over 3, I'm still on the line. So the slope is constant at 2/3. Now when you get into calculus, what makes calculus different than Algebra 1 is, suppose you were asked to find the slope of this line. Well, you've probably never been asked to do that before, unless you've seen a little bit of calculus. But as you can see here, the slope is changing. Here, the slope is increasing, but on the left side, the slope is decreasing. Now, in Algebra 1, the slope has always just been constant. In this case, it's positive. But over here, it depends upon where you're at on the curve. Over here, it's positive. Over here, it's negative. And at the vertex here, the slope is actually, at this point here, the slope is 0. Okay? So when we have curvy lines, something like a parabola, the gradient or the slope is changing. And the best definition of calculus is the mathematics of change. All right, so what is, going to my first question here, what is a derivative? What is a gradient? What is a slope? It's simply this, it is the rate of change somewhere along the curve. Okay, so in short, the gradient is simply slope. What makes the calculus portion weird is that when you have a curvy line, the slope is not a pat answer like 2/3. Okay, so let me back up some of the markings here. All right, so how do you find the derivative? Well, there's something called the power rule, okay? And the power rule, if you look in the lower left-hand corner of the screen here, so before I do the green parabola, let me just walk you through the power rule. The power rule is a process in which you take the exponent and you multiply it to the coefficient in front. 2 times 3 is 6. And then you're going to subtract 1 from the exponent. 2 minus 1 is a 1. Okay? So this first monomial here has a slope of 6x. Now if we do the power rule on the second piece, this is 6x to the first power. Remember the steps again. It's multiplication and then subtraction. So we're going to take the exponent of 1. We're going to take the exponent of 1 and multiply it to the 6 to get 1 times negative 6 is negative 6. And then we're going to subtract 1 from the exponent. Well, 1 minus 1 is 0. So you get x to the 0 power. Okay? Now, this little constant here at the end, the plus 4, I want you to treat that as 4x to the 0 power. All right? It's a 0 power monomial. Now, if you do the power rule on x to the 0, remember what you do again. You multiply by the exponent. So 0 times the 4 is 0. It goes away. So if we were to simplify the gradient or the slope of this black trinomial here, we would say that the derivative, or the gradient, would be 6x minus 6. Now that's very, very strange to Algebra 1 students because the slope has always been a constant, 2/3. But in this case, notice that the gradient or the slope has a variable in it because the slope is changing. Okay, so let me show you the power rule on the green parabola. If you don't understand the power rule, you're going to want to pause this video, watch another video on the power rule on polynomials before I go back and show you the other questions. Otherwise, you're going to be lost. Because when I get to the IB questions, I'm going to move very, very fast. I'm going to assume you know how to do the power rule. All right, so if I want to find the slope of the green parabola, notice I'm using the little ticky there. I'm going to take the exponent of 2, multiply it to the front coefficient. There's a 1 there, so 2 times 1 is 2, and 2 minus 1 is a 1. And remember, every constant, like the 4 over here, the derivative or the slope of every constant is 0. Okay? So in other words, we would say that the gradient of this green parabola is 2x. Now, if I want to know the slope at particular x values, the slope at x is equal to 1, all I have to do is plug in 1 there. So the slope at 1 would be, 2 times 1 is 2. Now, if you look at the parabola here, we're running out of colors here. Let's go to purple. If you go to the parabola, if I go over to x is equal to 1 on the parabola, here is 1, and I go up on the curve, and I put a dot there, and I draw a tangent line. The slope of this purple tangent line is 2. Okay? Now let me pick another point. How about I want to know the slope at x is equal to negative 2. Well, if I take the negative 2 and I plug it into the variable x, it's going to give me the slope at negative 2. Well, 2 times negative 2 is a negative 4. Now, if we verify that on a graph, go over to x is equal to 2 on the parabola. Follow the purple again. Here's a negative 2. And if I put a point at negative 2 on the parabola, I want you to notice that the tangent line is got a negative slope, and it's very, very steep. Namely, the slope would be a negative 4 because it's going downhill. So as you can see, when you get into calculus, sometimes the slope can be positive, sometimes the slope could be negative, and that all depends upon the given x value you're working with, okay? So the slope is changing. Okay, one last thing before I go to the IB questions, the moment you have been waiting for, but I wanted to get a little bit of theory done first. I wanted to talk about this here before you get into the application of it. So here is a very, very important thing here. I want you to notice at the vertex of a parabola, at the minimum point, the slope is 0. It's horizontal. And if you plug in x is equal to 0 in here, what do you get? 2 times 0, which is 0. So write this down right now. The slope or gradient at a minimum point or a maximum point will be 0. That is going to be key on the application. So max min point has gradient of 0. Okay? That's because at a max and a min point, you have a peak or a valley, and if you draw a tangent line there, it's horizontal. Okay, let's go back to our questions here. All right, so let's go to part B here. I'm assuming you know how to do the power rule. You are ready to rock and roll. So I'm going to take part B. It's asking you to find the derivative. And right here, we got a quadnomial here. So I'm going to remember the power rule. It's multiplication and subtraction. You multiply by the exponent, you take the 3, multiply to the 4, and then you always subtract the number 1 from the exponent. 4 times 3 is 12. 3 minus 1 is 2. The second piece, 2 times negative 9 is 18. 2 minus 1 is a 1. Done with that piece. Now I'm on to the third piece. The exponent on that is a 1. 1 times negative 12 is minus 12. X to the 0. This is the same thing as 1. I'm only writing it so that you see the power rule, the process. And then the derivative of constant goes bye-bye. It goes to 0. Goodbye. So notice that the original degree is degree 3. My derivative or gradient is degree 2. So the degree will go down 1 each time you take the derivative. So the answer to part B here is this trinomial, 12x squared minus 18 minus 12. So that is the how to find the derivative. Now I want you to notice the very next question is an application of that. Okay, find the local maximum. There's the word maximum. And remember what I told you. The derivative or gradient of every maximum point, here's the maximum. If I draw a tangent line, the slope of this red line is 0. And at a minimum point, here's the minimum point, the slope is also 0. So, in other words, I'm going to take this purple thing here, I'm going to set it equal to 0, and I'm going to factor and solve, and I guarantee you it's going to give me two x values. The first x value is going to tell me where there is a minimum. The second x value is going to tell me where there is a maximum. So here we go. 12x squared minus 18 minus 12. I'm going to switch to black here. And I'm going to set this equal to 0. Why am I setting it equal to 0? Is because it's asking for a maximum. Okay? And maximum or minimum points have a gradient of 0. That's the application part that students seem to forget because it doesn't explicitly tell you right here what to do. It just says find the maximum. It doesn't say take the gradient, set it equal to 0, and solve. It says find the maximum. You're the one that's going to have to say maximum has a slope of 0, has a gradient of 0, so I'm going to set the function equal to 0, factor, and I can't take out an 18. Believe it or not, I haven't done this question yet, so I'm kind of surprised. All right, looks like I can take out a 6 here. 2x squared minus 3. Okay, the 6 I can cancel. I need to factor this thing here. So I got a 2x. And this is minus 1. This has got to be plus, no, this got to be plus 1, and this has got to be a minus 2. Yep. Okay, so if I factor this, and if you don't know how to factor this, that's a whole nother ball game. But I factor this trinomial, as this binomial times this binomial. And if I set this equal to 0 and solve for x, I'm going to get x is equal to negative 1/2. Okay? That is where the function has a maximum. Okay? So that's the answer to part C. Now, where is there a minimum point? That's the other package here. So this yields x is equal to 2, and that is where on the graph there is a minimum point. Okay? So notice that this equation, this black derivative or gradient, gives us two x values, negative 1/2, positive 2. Both of them have a slope or gradient of 0. Hope you're following all my little markings here. Both of them have a gradient of 0 because at a max and a min, the gradient is 0. Okay, so going on to the next question. There is a little trick, something to be careful with. Notice that this right here, and this doesn't show up every year on the IB test. It's sometimes on a paper 1. They'll just ask you to find the gradient, and that's it. They won't ask you to apply it, but they'll ask you to take the gradient. And I want you to notice that there is a variable in the denominator of a fraction. You cannot do the power rule in the denominator. So, for example, if you're given a function like 2 over x cubed, the gradient of this is not 3x squared. You cannot take you cannot do the derivative or the power rule in the denominator and just get that. And 9 students out of 10 intuitively just do that, and it's incorrect. Okay? So how do you take the derivative of that? Well, you first move the x cubed to the top. Okay, so your Algebra 2 skills, you should know that a negative exponent means reciprocal. So you'd move this to the top, or the numerator, and rewrite it like this. Now it's ready to take the derivative, or the gradient. So I do negative 3 times 2 to get negative 6. And here's the kicker. Remember, you always subtract 1 from the exponent. Negative 3 minus 1 is a negative 4. And then if I write this nice and pretty again, only the x is being raised to a negative power, so only the x gets flipped. So that would be the gradient of that one. So going back to our original problem, f of x, I'm going to move the x to the numerator, and then I'm going to take the derivative. All right, so this is not the derivative or the gradient, but I'm getting it ready to take the derivative because you cannot do the power rule in the denominator. So be on the lookout for that. Do not do this thing here. All right, so f prime of x, the way you'd say that in calculus is prime. You really don't call it ticky mark. That's just my name for it. Okay, so we're going to multiply by the exponent and subtract 1 from the exponent. Okay? 1 times 1 is 1, and the constant 6 goes bye-bye. So, in other words, the answer to this is simply that. Okay? Now, so that is how to find the derivative. You use the power rule. Power rule. Power rule. And then I'm going to stress one more time, the IB is so concerned with you applying things. They don't want you to just simply blindly do math calculations, but to actually apply it. So be ready. Every time you take the derivative, they're going to ask you, use your answer from part B, which is this, to apply it, okay? To show that the x coordinate, oh, there it is again, the minimum, remember what I said here, the max and the min have a gradient of 0. So, has a local minimum at 3.7. So all I'm going to do is I'm going to take the derivative. I'm going to move the x back down into the denominator. And then plus 1. I'm going to set it equal to Oh, it doesn't tell me what to set it equal to. But I know because a minimum has a gradient of 0. Sorry for my sarcasm there. But just keep in mind, every time you see the word minimum or maximum, think derivative equals 0. Derivative equals 0. Gradient equals 0. All right, so I'm going to solve this guy here. And I'm going to subtract 1 from both sides. And if you cross multiply, you're going to get x squared is equal to 14. And if you take the square root of both sides, you get plus or minus square root of 14, which I'm pretty sure is 3.7. So that's how you do that particular problem. Now keep in mind that this question has 21 parts to it. I've only done, this right here is only about 6 of those points. But that's the only calculus portion. That's the good news. All right, last question here. So here we go. Here we have a function. It should have the same song and dance here. Here is the little ticky mark there. This is all algebra 2, but here's the calculus portion. So I'm going to do 2 times negative 0.2, so that's negative 0.4 t to the first power, because I subtract 1. And that's t to the first power. 16 times 1 is 16. And then 1 minus 1 is 0, so that goes away. And then the constant goes bye-bye. So, find the derivative. No problem. I just got 2 points for doing the power rule. I just got 2 points for multiplying and subtracting. Easy points. Now, show that the flare reached its, there's the word again, maximum has a gradient or slope of 0. Maximum has a gradient of 0. So hopefully I'm brainwashing you that every time you see the word maximum, every time you see the word minimum, you're going to think derivative equals 0. Okay, so all we have to do here is take the gradient, set it equal to 0. So I'm going to subtract 16 from both sides. And then I'm going to divide by negative 0.4, not t. And I have a hunch that negative 16 divided by 4 is 40 seconds. So notice they're asking you to just show that. So they want you to apply the derivative. They're telling you what the answer is. It's 40 seconds. But they want you to show it. And the way you show that is you take the derivative equal to 0. All right, so this is a crash course in, just before I move on here. What you would do is you take the 40 now, and you take the 40 and you'd put it into the original function. Everywhere there's a t, you'd put it here, and you'd put it here, and that will give you the maximum height, because you're looking for height in this case. So if you want to know height, you have to go back to the original function. H stands for height. So you don't take the 40 and put it into the derivative, because that is a gradient. You want to know the height, so you're going to take the 40 and put it into t here, because 40 is in seconds, and that will give you your height. All right, so this is a crash course in gradients. There is a lot more, obviously, to the IB test, but I'm just trying to give you an idea on how to know what a derivative is, and the IB word for derivative is gradient. In AP Calculus in the United States, we use the word derivative. Okay, in Algebra 1, we call it a slope. It's just a rate of change of rise over run. How to find it? It's called the power rule. Okay, how to apply it? They're always going to be using max and min. These particular questions that I showed you did not have geometry, but also be on the lookout that you're going to have formulas with volume, surface area, area of a square. those also could, you can maximize or minimize the volume or surface area, same concept.